Okay, so here's the review video for this worksheet that we did in class. Let's start with this problem here, Pythagorean theorem. We need to remember how to use this and when to use this. We can only use this when we have right triangles, right? And we're trying to solve for the missing side. So the formula here is a squared plus b squared equals c squared, okay? And the reason why we can only use this during a right triangle is because whenever we have a right angle, it gives us the hypotenuse, right? And the hypotenuse is always the greatest side, the longest side of a right triangle. So the hypotenuse is always across from the right angle. So that's going to be our C, okay? And then the legs of the right triangle are A and B. It doesn't matter which one goes into which. I'm just going to plug in A for X and then B for 5 for B, right? Once we plug in our numbers, it's just simplify. X squared, and now we're trying to solve for the missing side, X. So X squared is going to stay that way. I'm just going to stop color coding now. X squared, 5 squared. This exponent means squared or power of 2, right? I'll kind of say the same thing. Sometimes I'll say 5 to the power of 2, or sometimes I'll say 5 squared. It means the same thing though. That means 5 times 5. That's the same thing as 5 times 5. So that's got to be 25, right? 13 squared is 13 times 13, so it's going to be 169. Okay. Now we're trying to solve for x, minus 25 on both sides. X squared is 144. And then now, if we want to get rid of this the square, all right, how do we get rid of this? You have to do something called square root both sides. This is called square root. If you square root both sides, those are opposite operations. Okay, so that turns into x equals 12. Right, so a little bit of review, right, on x squared, or squaring a number. That's 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and it keeps going on, right? But from here, if you take that 25 and you square root it, what do you think it's going to go back to? Yeah, it's going to go back to 5. Same thing here. If you take 16 and square root it, it's going to go back to 4. Square root of 9 is 3. Square root of 4 is 2. And then square root of 1 is 1. So if you square root like a number that's not one of these, then like think about like square root of 3. And it's probably going to be between these two numbers, right? So it's going to be like 1 point, I don't know, like probably like 1.7, something, I don't know, right? If you plug it in, it'll get you a really long decimal that goes on forever. So these are called perfect squares, right? They kind of just turn into a perfect whole number instead of a decimal, okay? So yeah, 144, if you square root it on the calculator, you're going to get x equals 12. That's your final answer here. So try out number 2 on your own. All right, I'll do number 3 and number 4 real quick. So number 3, it's the same thing, same formula here. A squared plus b squared equals c squared. Equals c squared. I'm only going to color code one more time. I'm going to color code after this. C, always start with your C. I see my right angle here. Across from the right angle is square root of 257. All right, so I'm going to plug that in as my C. And then it doesn't matter which one is which again, 10 squared plus x squared. Okay, so let's go ahead and solve for x. I know 10 squared is 10 times 10, which is 100. X squared stays the same. What happens to this here? Square root of 257 squared. So let me kind of show my work on this side. Remember, when you're squaring something, what are we doing when we're squaring something? We're multiplying the number by itself. So this means you're doing square root of 257 times square root of 257, right? And then if I'm multiplying two square roots, you just multiply those two numbers under the same square roots. So 257 times 257 is going to get you 66049, 66,049. Now if I square root this 66,049, you're going to get 257 again. So what's really happening here, right? I said at the beginning, square roots and squared, they're opposites of each other. So when you have them right next to each other like this, you could just cancel them out. And it just goes directly into 257, okay? But this is really what's happening here. You're multiplying them and then square rooting it, so you get 257. So here, this is going to be just 257, okay? Minus 100 on both sides. X squared is 157. Now you square root, right? To get rid of it, again, they're opposites of each other, so you cancel them out by square rooting. Right here, we're going to get, if you do the square root of 157, you get, again, a really long decimal. You're going to get, I'm going to write the whole thing, 12.52996409, and it goes on forever. The direction said round to the nearest tens place. So let me, let me go ahead and, round it. Tens place is the first number after the decimal. The number next to it is going to help us determine, are we staying at 5 or are we moving up to 6, right? We're asking ourselves, is 12.52 closer to 12.50 or is it closer to 12.60? Obviously, it's closer to 12.50, so we're going to round it to 12.5, okay? That's our final answer. So let me do number 4 real quick. I'm not color coding on this one. A squared plus B squared equals C squared. Which one is our C? It's going to be 2 square root of 3. Okay, notice how I put the parentheses there? Because I have more than one term in there. This is 2 times square root of 3. If I don't put the parentheses, it just looks like I'm squaring the square root of 3. I want to make sure I'm squaring both of them, right? I'm squaring all of this, not just this. So you have to put the parentheses there. 3 squared is 9. And then x squared stays on its own. So let's talk about what this gets us. What does this mean? 2 squared or 3 squared is basically you're multiplying it by itself. You're multiplying it by itself. And when you're multiplying this, 2 times 2, you multiply like terms. 2 times 2 is 4, and then square root of 3 times square root of 3 is square root of 9. You're going to start asking yourself, can I simplify this even more? 4 stays the same. Square root of 9 is a perfect square. That's 3. So 4 times 3 is going to get you 12. All right, so same thing. This turns into 12 minus 9, x squared equals 3, and then square root, okay? Simple stuff here. This should round to 1.7. That's your final answer. Okay, Pythagorean theorem, get used to it. You're going to need to use this in some of your problems on the final. These proportions, you should know how to do these. They're very straightforward. Like all you have to do when you have two fractions equal to each other like that, you just cross multiply. You get 6 times 4 equals 2 times x. 6 times 4 is 24. And then just divide both sides by 2. Okay, x equals 12. X equals 12. Oops, sorry, I don't know why it's moving like that. There you go. And then same thing here. Right, cross multiply. I'm only going to show you one more. Cross multiply, get 5 times 10 equals 2 times, and remember, you're multiplying all of it, k minus 7. You're not just multiplying 2 with k and then leaving 7 by itself. You're multiplying everything, so you have to put the parentheses and then distribute. All right, so 5 times 10 is 50, 2 times k, 2k. 2 times 7, 14. And now it's just algebra. add 14 on both sides, divide by 2, you should get 32. K is 32. Okay, keep working. Try the other problems out on your own. I did post the answer key on Schoology. So 9 and 10. I'm going to do 9. 10 is very similar. So 9, again, these two triangles are similar. Fill in the similarity statement and state the ratios that must be equivalent between the two similar triangles. So let's start with this. RST, there's two triangles here. I like to redraw them separately because it's easier for me to figure out the corresponding sides if I draw them separately. Okay. So RST, right? I'm going in that order, RST. So then on the other triangle, I should go in the same order, triangle RLM. So that's my similarity statement. What are my ratios that I'm going to use? What ratios am I writing down? Here, there's a lot of different ways to set up your ratios. I could start by picking my corresponding sides. I know RL matches with RS, so RL over RS equals. And then I need another pair of matching sides. I could use ML and TS. ML and TS. But notice how I kept ML and RL both in the top of the fraction? Because I started with RL. I'm going to make sure I start with ML. Okay? So kind of take a moment to think to yourself, what is my next ratio going to look like? Yeah, RM, RT. Again, start with RM and keep all of the small sides on top and all of the small sides, the bigger sides on the bottom. You could flip it, right? You could put RS over RL, but if you do that, make sure you flip the rest of the ratios. Okay? You could even do this. You could even do this. You could even say RS over TS is equal to, and then set up the other ratio the same way, RL over ML, right? You could even do this. You could even do RL, oops, sorry. I want to mess this up. RL over LS is equal to RM over MT. You could even take parts of the side and set up a ratio like that, okay, as long as they're matching. So any of these work. Try out number 10. Okay, I'm going to do a couple of these problems, but from now on, 11 through 20, all of them could be solved the same way. So maybe I'll just do 3. I'll just do 3 of them, and I'm going to expect you to be able to try the rest on your own. Let's look at number 11, right? You can solve these using 2 different methods, using the scale factor method or proportional method. Scale factor works for only some problems, but proportional works for all your problems. Okay, so I would definitely remember how to do both of them because you need to know how to use the scale factor, but it's also easier to set up your proportions. So again, I like to start these problems by drawing the triangles separately. I know this side is 12, so I'm going to put 12 here. I don't know this side yet, right? That's this side right here. Let's just call it X for now. And then I have the bigger triangle all together. So the bigger triangle, this side is going to be 3 and 12. 3 and 12 together, right? Do you see that? 3 and 12. So 3 plus 12, we know that's 15. Oops. And then this side all together, all of the bottom side is 20. Okay. The entire bottom side is 20. So the game plan here is figure out what X is, and then since X is only this part of the line and 20 is the entire line, we could just subtract them to get the missing side. So from here, I'm going to show you how to use scale factor to solve for X, and then I'll show you proportions for another problem. But you could also use proportions for this problem too. Remember, scale factor is always image over pre-image. What does that mean? Image is where you end, and pre-image where you start. So we're trying to solve for x. So that's this triangle is where we're going to end up. So this one's your image. And then we're starting from the bigger triangle. We're going from the bigger triangle to the smaller triangle. So this is your pre-image. So this is your start. So how do we go from 20 to x? What is x going to be? So we're going to use these two sides, 15 and 12, to set up our scale factor. So we said 12 is the image, 15 is the pre-image. And this makes sense. We're going from the bigger triangle to the smaller one. So if we're getting smaller, we're shrinking. Our scale factor, 12 over 15, has to be less than 1, which is true. Let's simplify this. Both of them are divisible by 3. So 12 divided by 3, that's 4. 15 divided by 3 is 5. So our scale factor is 5. I need to multiply 20 times 4 over 5. Right? If we multiply 20 by 4 over 5, we're going to get x. So multiply, when we're multiplying a fraction and a whole number, multiply 20 times 4, which is 80, divided by 5, 16. So x is 16. Sorry, I'm not going to box it because that's not my final answer. And then if we know the entire line is 20, part of it is 16, 20 minus 16 is 4. Okay, that's what's left over. So 4 is your answer here. Again, you could use proportion for this problem too, but I just chose to use scale factor to show you what it looks like. How do you use the scale factor to solve for the missing side? Let's look at number 12. And I'm going to solve for number 12 using proportions. Okay, this one actually doesn't work with scale factor. So even if you try to use scale factor, it's not going to work. Let's try this one out. Again, practice drawing the triangles separately. So this part is 6. And then this bottom part is question mark. Let's just call it x for now. Let's call this x. And then the bigger triangle, the entire side is 10, right? And this side here, this side down here, it's all of this together. So this part is 10 and this part is x. So together it's going to be 10 plus x. Okay, that makes sense. 10 plus x. So let's set up our proportions, something like we did up here. Right? And it doesn't matter how you set this up as long as you match them accordingly, like you match them correctly. So again, it doesn't matter which number we want to start with. I'm just going to start with 10. Okay, so if I start with 10 on the same fraction, I just need to make sure I pick the matching side. So 10 matches with 6, right? So I'm going to make sure I put 10 and 6 on the same fraction. I started with 10. So on the other fraction, I'm going to start with the other side, 10 plus x. And that matches with x. So I want to make sure I put them together on the same fraction. Okay? This is how you set up a proportional relationship. They're saying that the scale factor you use to get from 10 to 6 is the same scale factor from 10 plus x to x. It should be the same thing because it's all proportional. This is a dilation. These two triangles are similar, so everything should be this. The scale factor should be the same. You set up your ratios, cross multiply, 10x equals 6 times 10 plus x. Now it looks like the problems we did earlier. Cross multiply, that's 60 plus 6x. We don't need both of these x's, so let's take away one of them on one side. 60 equals 4x. And yeah, you just divide by 4 and you get 120. Let's see. Sorry, I'm just 15. Yeah. Huh? So x is 15. That's it. Right? X is 15. These problems, you could do them on your own, right? I want to tell you on number 14, you could, let me set up the ratio for you. You could also set it up like this. When you set up your proportions, you could set it up like 5 over 2, right? 5 over 2 is equal to, and x over 4. You could set up your ratio like that. That's totally fine. We have two parallel lines. These two triangles are similar. You could do 2 over 5 instead. You could flip it. Just make sure you flip the other fraction, 4 over x. Okay? Those are valid ratios you could use. And then cross multiply and then solve for x. Okay. I want to do one more. I'm going to do one more. Let's do number 15. 15. Okay. Number 15. And then again, down here, it's the same thing. Set up your proportions, solve for the missing side, or you could find a scale factor and solve for the missing side. Can you do scale factor on this one? You can't do scale factor. I want to do one where you could use scale factor on both. Let me set this one up for you and I'll do a different problem. So number 15, you could do 9 over 15. 9 over 15 is equal to, and then set up the other fraction, all right? The other ratio, 21 over 2x plus 17. Or if you wanted to draw the triangle separately, you could also do this. This is 15, this is 2x plus 17, and then the bigger triangle altogether is 9 plus 15, that's 24. And then here has to be 2x plus 17 plus 21, because we're combining them. So that's 2x plus 38. So this is 2x plus 38. And then set up your ratios, your proportion. You could do 15 over 24, and then 2x plus 17 over 2x plus 38. It's extra work, but if you cross multiply, you should get your answer here. You'll get the same answer if you did this version. Cross multiply. Okay. Let me do this one. Let me do this one. Okay. So I'm going to do both methods, scale factor and proportion. You only need one though. You don't need to use both. So let's do the proportion one first. Let me redraw my triangle. This is 6, this is 3. And then the bigger one is x, and this is 5. So again, I could do 3 over 5. 3 and 5 are matching sides, equals 6 over x. We cross multiply, 3 times x, 6 times 5. 3 times x equals 30. X is equal to 10. That's your answer. Or you could do the scale factor method. We're starting from the smaller triangle, and we're going to take that 6, multiply by some scale factor to get your bigger triangle. So this is your pre-image, and this is your image. Right? The scale factor is always image over pre-image. So I'm going to do 3 over 5. Those are the two sides that I could use, 3 over 5. So I'm going to multiply 6 by 3 over 5 to get my side here. So 6 times 3 over 5. 6 times 3, that's 18, divided by 5. That's not right. What did I do wrong? Good answer, good answer. Right? It should have been 5 over 3, not 3 over 5, because the image is 5, and then its pre-image is 3. I did it the other way. Okay? So good, 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 good. So that's 5 over 3. 6 times 5 is 30. And then divided by 3, that is 10. Okay, so again, I just did both ways to show you that both ways are correct, but either one works, whichever is easier for you. Okay. All right, I'm going to stop here, but the rest of the problems are the same thing. You should be able to do it. We've been practicing this for a while now. I believe in you. Okay, good luck.